Good day everyone, welcome back to our physics series. Today we'll be discussing the topic motion. Motion. Motion is the change of position of a body with time. There are two branches of motion. The first branch is kinematics. This studies the motion of an object without considering the forces causing the motion. While the second branch is dynamics. It studies the motion of objects and the forces that cause or change that motion. Types of motion. There are four main types of motion, namely random motion, translational motion, rotational motion, and oscillatory motion. Random motion. This is the motion of objects or particles irregularly, haphazardly, or disorderly without preferred direction. The particles collide with one another and with the wall of their containers if they are kept in containers. The Brownian motion is a description of random motion. Other examples are motion of pollen grains suspended in water, motion of chalk or dust particles suspended in air, motion of smoke particles suspended in air. Translational motion. This is the movement of rigid bodies from one point in space to another without rotating. Each part of the object undergoing this kind of motion follows the same path. Examples are a bee flying from one flower to another, a car traveling from one station to another, and aircraft flying in space. Number 3, rotational motion. This is the kind of motion in which all points in the body move in concentric circles. The center of these circles all lie in a line called the axis of rotation. Examples are rotation of the earth around its axis, motion of the wheels of a moving car, and motion of the blade of electric fan. The fourth type of motion, oscillatory or vibratory motion. A body is said to undergo oscillatory motion when it moves to and fro, reversing the direction of its motion and returning regularly to its original position. The motion is periodic because it repeats itself at regular intervals. Examples are motion of swinging pendulum, motion of a diving board, motion of the plucked strings of a guitar, motion of the prongs of a turning fork, vertical motion of the mass on a spiral spring when distributed. Relative motion. Motion is defined as change of position. However, it is impossible to determine the change of position without a reference point or frame of reference. It means therefore that every measurement done to determine the motion of a body must be taken with respect to such points or frames of reference. Relative motion can be defined as a motion of a body with respect to another. All objects moving on the earth's surface have relative motion with respect to the earth, which is assumed to be stationary. If a ball is standing on a moving train, its speed with respect to the earth is the speed of the train. If the ball in the train runs inside the train towards the direction of the train, then its speed with respect to the earth is the speed of the train plus the speed of the ball. If the ball runs backward opposite to the direction to the train, then its speed with respect to the earth is the speed of the train minus the speed of the ball. Consider two cars A and B approaching each other in the opposite direction. If A moves with a speed of 40 km per hour while B moves at 50 km per hour, then the speed with which they approach each other is 40 plus 50, which is equals to 90 km per hour. On the other hand, if both A and B are moving in the same direction at their respective speed stated above, and with A ahead of B, then the speed with which B approach A is 50 minus 40, which is equals to 10 km per hour. In summary, if they are going in the same direction, we subtract their velocity, and if they are going in opposite direction, we add their velocity. We have an exercise that states that two cars S and Y traveling in opposite directions along the same highway at uniform velocities 110 km per hour and 90 km per hour respectively pass each other at a certain point. The velocity of S relative to Y at the time they pass each other is, and we are given the option. For our solution, we are going to represent this in a diagrammatic form as shown on the screen. If Y were to be stationary at that point, the velocity of S relative to Y would be 110 km per hour. That's the velocity of S. Now that Y is also moving but in the opposite direction, S will be separated from y at a much faster rate. That's the sum of their velocity. Thus the velocity of s relative to y will be equals to 110 plus 90, which is equals to 200 km/h. We have some exercises, and the first is from WAEC 2017. It states that a body can undergo the following types of motion except A. Random, B. Rotational motion, C. Translational motion, and D. Relative motion. All types of motion are relative motion, and relative motion is not a type of motion, so the correct option is D. Our second example states that relative velocity is the velocity of an object A with respect to the ground, B with respect to another object, C at maximum speed, and D in a circular path. Now relative velocity and relative motion are the velocity of motion of an object with respect to another object, so the correct option is B. For our third example, it states that a car moves east at 20 meters per second while another car moves east at 15 meters per second. The velocity of the first car relative to the second car is A. 5 meters per second east, B. 35 meters per second east, C. 5 meters per second west, and D. 15 meters per second east. Now since they are both moving east, which means we are going to be subtracting their velocity, so 20 minus 15 will be 5 meters per second and will still be in the eastward direction. So our correct option is A, which is 5 meters per second east. Now we have our final theory question, which states that a train moves at 30 meters per second east. A passenger walks inside the train at 2 meters east relative to the train. What is the passenger velocity relative to A, the train, and B, the ground? Now the velocity of the passenger with respect to the train has already been given in the question, and is 2 meters per second east. Now for the B part, that's the velocity of the passenger with respect to the ground. It will be the velocity of the train plus the velocity of the passenger, which should be 30 plus 2 meters per second, which should be 32 meters per second. So the velocity of the passenger with respect to the ground is 32 meters per second. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out the chapter 2 of our Hidden Facts Physics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.